Hi, welcome to Ethereal Mechanics. We're going to review Ampere's force model. There's a researcher named Physicists whose videos are starting to get around, and this was sent to me by a Patreon member. And the interesting thing is he's promoting one variant of Ampere's force model, but there's a much more interesting variant that we're going to cover. We're actually going to cover all the variants. Now, what I'm trying to do to try to make my videos flow a little bit better is I'm going to break them up into two sections. The first section is going to be the general audience synopsis. I'm not going to get into too much of the gory details. I'm just going to give you a 2 to 5 minute synopsis. Well, somehow these keep coming out to 10 minutes every time I record it, but whatever. I can't seem to make them any shorter. And then we go into the engineering deep dive, where I'm going to show you that there's a variation of Ampere's model that they pretty much threw away, that had they followed it would have dovetailed with the new electromagnetism fragmentary force model, magnetic force model. And that could have been a gateway for them to derive the whole kit and caboodle. But again, I don't know why, but these physicists seem to throw away perfectly good things for ridiculous reasons, and I'll show you the reasons in the deep dive that they threw it away. So Physicists is promoting Ampere's force model, this variant of it specifically. Okay, now, when I first saw this, I thought it was a scam because there's a lot of people out there that put up a lot of stuff and then they say, oh, this is, Tesla's lost secret, or they just name drop somebody so they can get their pet model promoted. And so that's what I thought this was in the beginning, but then after I researched, I found out I have seen this before, and I discarded it long ago for reasons that I'm going to show you. This pretty much here says that two parallel fragments provide twice as much attractive force as they should. So this variant of Ampere's law that Andre is promoting is just not satisfactory because it just doesn't match a lot of experiment. Okay, if you go to Wiki Ampere's force law, you will find the general form of Ampere's force model, which is all this big nasty stuff here. The important point here is the little k's that are distributed through the model. Not this one. This one here is a constant of relation. But all through the model, there's these little k's. And so there's two groups of researchers back in the day. Gauss and Riemann believed that this model matched nature better when k equals +1. And then Ampere and Weber believed that this model better matched nature when k equals -1. And that's also being proposed by Physicists, the researcher described in the video previously. And so if we plot the general field footprint, now these aren't perfect representations. They just basically show the magnitude of the coefficients in all the directions. So don't take these as the actual shape. I mean, for example, this shape over here would look more like something like this. Or this would be minus for attraction. This would be plus for repulsion. Okay, but the general coefficients would be 2 over here and 1 over here. So that's what I'm going for. This is just the general coefficients. Now, the interesting thing, and we're going to cover this in the deep dive, that if you take this as it is and you do the translation of the final vector model to a vortex model, you end up with a new electromagnetism V5 fragment-to-fragment magnetic force model. That's not all of new electromagnetism. That's one small derivative part. But interestingly enough, it could have been the gateway that would have given them the whole kit and caboodle. Okay, and so this is cool. I didn't know this before because when I looked at this model 20 years ago, I had not developed vortex algebra, so I missed that. So I didn't know that would have been the gateway. Otherwise, I would have used that gateway to get into new electromagnetism V5. But anyway, we're going to talk more about that in the deep dive. So, but if we stay with the k equal +1 route here, the silly thing is that legacy researchers, okay, Maxwell Heaviside, they decided to throw out half of this spherical field phenomenon, toss it in the garbage, and then retain the Biot-Savart field model, which is like a donut around a current fragment. This is like if you take a donut and you take a slice out of the donut, this would be the donut hole. That is basically the field footprint of the legacy Maxwell Heaviside models. Okay, and that's what we basically call, it's not fully classical theory because Einstein made a little tiny addition to this, and we're going to talk about that in a moment. Okay, but let's look at now all of these different variants that we're going to cover. Okay, so we have the Ampere K plus minus 1, which is the one that Andreas Sissis is promoting. We have the K plus 1, which was Weber and Gauss. And then we have the classical magnetism model, which is basically this K plus 1 minus out the longitudinal component. And then we have a variant of it, a tiny variant, where Einstein basically discussed the velocity of the B field. We'll talk about that in a moment. Okay, and then we have new electromagnetism V5, the fragmentary force model, or the fragment-to-fragment magnetic force model. This should be magnetic force model should be in there. Okay, so let's look at the first experimental variation that Andre talks about. He talks about, in this example, is a fragment of wire carrying a current and another fragment of wire carrying a current. And the force between them, according to Ampere's force law, which he is a proponent of, has no force between them. Okay, so on the other thing, with the other, we'll just call this legacy, regular classical theory, these two fragments do have a force. Okay, but he's arguing that because there's no reactionary force, that this violates Newton's law of action. Basically, Newton's third law says for every action there is an equal and opposite reaction. Okay, he is correct. That does violate that Newton's third law, but I don't think it's a problem with magnetism because this is observed. Okay, we actually see this, so that makes this wrong. Again, we're not here to agree with Newton. We're here to agree with Mother Nature. So that this is correct means that Newton's laws need to be revised. And I think I have a way of revising them. I'm going to come out with a full revision when I come out with the Ethereal Mechanics cosmology. And basically the thing is, every force in nature is transferred by fields, and fields do not transmit instantaneously. So there actually would be, in the course of a time, a action would come back to this. It just doesn't happen in this one field coupling. Okay, so what we should be saying for Newton's law is for every action there will be an equal and opposite reaction, because nothing is instantaneously, especially if you're requiring fields to transmit all of your reactions and reactions. You're not going to get a response instantaneously. Okay, so that's important, that Newton's law, all three of Newton's laws need to be revised in ethereal mechanics. And I think the way I'm going to revise them, I believe that physicists will be okay with it. Okay, so, but anyway, the more important point is this is observed. Okay, so we got the two cases here, this one and this one. So let's see how the forces stack up. Okay, so Ampere K equal minus 1, which Andre is promoting, falls into this camp where there is no force in this particular case. And all of the rest of the models agree with this force that occurs. Ampere's K plus 1, both classical theory, both the Einstein variant and the normal one, and all of the new electromagnetisms from the very beginning to now cover this field effect. And again, this is an observed effect. Okay, next you have the case of two coaxial wires here, and with current going in the same direction, and according to Andre, there should be a repulsive force here. Okay, and in classical theory, there is no repulsive force here. Now, the reason why there is no repulsive force here is because classical theory, like I said, threw out the longitudinal component, which would have covered this. Okay, but everybody except classical theory agrees with this. Now, this is a difficult point because it's difficult here to observe this effect, because this effect does go to zero. When you just take two loops of wire, this longitudinal effect does go to zero. So it's almost impossible to observe this effect. But I'm going to be trying to come out with an experiment to expose this effect somehow. It's not a high priority because the models agree with everything we observe. It's just this part is hard to observe because we would need to take open loop measurements in some nature to verify this effect. Because like I said, in closed loop measurements, this effect goes to 0. Okay, and then the parallel wire experiment, the one he does not bother to cover, this is important. He does not cover this because it disagrees with the theory he's trying to promote. Because everybody agrees with this except Ampere k equal -1, which is the variation that Andre is trying to promote. Okay, and so you can see this is what everybody does when there's a case that disagrees with their theory. They never show it. This is not how we should be doing science. Okay, I'm an engineer. I want models that work. It's not about, oh, I got to promote my theory so I can get clicks. It's not about that. I cannot do my job as an engineer with the garbage models that are out there and with people like Andre promoting things that are obviously wrong from their face. Okay, and getting out there and we're just confusing everybody with all this bullshit that's out there. Okay, so if we do the experimental wrap up, okay, this is how everything falls out. And the reason why this says, yes, the effect is there, the reason why it is wrong because it gives twice what we measure. So that's why this gets a failure, a red flag here. Okay, so right off the bat, like I said in the very beginning, the k equal -1 model is not, it fails experiment tremendously. Okay, now this column in the middle is the longitudinal effect that we still have to really confirm. I'm very sure it's there by a lot of ancillary things that go on. And some of the experiments that Andre promotes in his video are quite compelling, especially the exploding wire experiment. Okay, but I don't think those are good enough. And I want to come up with something else so that we can verify this, but I'm very sure this has to be there. Okay, and you can see the only people that don't have it in there's classical theory because they threw out that longitudinal component. Now let's talk about the variation of classical theory, how Einstein updated classical theory. Now he didn't really update it. Okay, engineers have been doing this out of fiat. Okay, but Einstein's the one that recognized we've been doing this out of fiat. Now what have we been doing? Well, the problem that you'll see here is that nowhere in these models do we describe the velocity of the B field. Okay, here we have the direction and magnitude. And so what we would do, let me explain this experiment first. We have two magnets that are rotating around a axis here. They're spinning around, and we have this stationary loop of wire. Okay, this wire here, this D-shaped wire is stationary. These magnets rotate above it. So what we would do is we would use this Biot-Savart model here to compute the magnetic field at a distant point because of a small part of the magnet. Now, in ethereal mechanics, we treat a disk magnet as a current ring. So we take a fragment of that current ring, and then we compute the intensity of the B field at this point. But what we don't have here is the velocity of the B field. Okay, if we took that the velocity of this fragment here is the velocity of the B field, we would get the wrong answers. Okay, so Einstein chimed in and he basically said, well, the way we compute the B field is we have to assume that the magnetic field moves with the magnet. And because these magnets are spinning around this axis here, we have to add more information that isn't in the models to come up with the velocity of the B field. So we take the rotation and cross it with the vector from the center of rotation to where we're trying to compute the velocity of the B field. Now, this works. This gives excellent answers for all of the paradox experiments. There's 54 paradox variants right now. I think we're going to be adding 18 more. And this gives the correct answers for all the paradox experiments. This by itself cannot give the correct answers. Okay, you need to add this other information, which is not part of the classical model set. Okay, now the problem with this is because this has nothing to do, this is outside of between the source and the target, this violates locality. And there's a lot of other things it violates. I've talked about it in one of the other videos. I'm not going to get into it. We violate, I think, 3 or 4 different rules of acquisition with this, which is not satisfactory. There's so many problems with this that it cannot be a fundamental model of nature because it is just too impossible to be true. Okay, that it gives correct answers, we can still use it. It's still useful, even though it can't be true. So if we put that in here, just using the classical theory without the new B field modification, they fail the paradox experiments. Okay, so does Ampere plus 1. And Ampere minus 1, I'm very sure fails, even though I haven't really run the math, but I'm very sure it does fail. But I don't really care. We don't really need this because we're already failing K minus 1 from these 2 points here. Okay, new electromagnetism V5 gets all the correct answers here. Okay, all the correct answers because it's based on vortex algebra, which takes care of all those rotations inherently. So now, if we just put a recent tally of all the experiments, and this classical here is the Einstein version of classical because it gets the correct answers for all the variants of the paradox experiments. New electromagnetism V5 passes everything so far. I mean, we're gonna keep experimenting because who knows, maybe there is a counterexample out there somewhere. We should never ever assume that our models or theories are irrefutable, just that we haven't found a counterexample yet. Those are the words of Imar Lakatos. Okay, so if you've made it with me to this point, all I ask of you is give me a thumbs up if you like this short synopsis of this video. And what I ask you is that just let the video run to the end, just because YouTube gives me brownie points, okay, for viewer engagement. So maybe I can get some brownie points if you just let it run to the end, even though you're going to go off and do something else. For those engineers that want to see the amazing thing that if you take Ampere equal K plus 1, okay, and we're going to follow Ampere's K plus 1 to show you how you can derive new electromagnetism V5 from it. But first what we're going to do, we're going to take Ampere's force model and we're going to convert it from this ancient hieroglyphics into a more modern vector representation, which would be this. And then when you put K equal plus 1 in there, it drops down to this model here. And so the interesting part is when you apply the vector identity, these two parts create the standard Biot-Savart donut-shaped model here. And this part, as I described before, is the longitudinal component that they threw away. When you add those together, you get pretty much a spherical. Now, if we go back to the wiki page and we follow what they did, okay, this is back at, this is Ampere's force model wiki page. And again, taking K plus 1, they obtain this. Okay, then they apply the triple vector identity to convert, I believe it is this guy and this guy into this. Now, they kind of made a mistake here because there should be an extra set of parentheses in here, but they recovered okay down here. Now, this part here, they say when integrating around ds, the second term is 0. And thus we find the form of Ampere's force law given by Maxwell. Okay, so they come out with the model that they want by throwing this away. Now, there's two ridiculous points here. The first ridiculous point is if your argument is that this goes to 0 around a closed loop, well then so does this. Both of these go to 0 around a closed loop. And therefore, if this is 0, then basically converting this using the identity is pointless. It's ridiculous. So that's number one. Number two is, why are we throwing this away? Only because it doesn't apply to closed loops. Now, maybe back in the day when they did this, they weren't aware of charged particles because they thought electricity was a continuous fluid. So maybe it made sense back then, but the caretakers of science today, where we're aware that charges can exist free of closed loops and can behave to fields even though they're not part of closed loops, she just said, why are we throwing this away? Okay, but the caretakers of science have done nothing. They've just basically accepted this old crap and not gone back and reviewed it to say, hey, we should bring this back. Maybe there's something there. Okay, and so there's no reason for them to be throwing this out, at least especially not today. Okay, and you know, this is the same thing. The physicists throw out things that disagree with what they want. You know, just like, oh, well, yeah, we can't get any good answers with the ether, so we're going to throw the ether away. The ether concept was perfectly sound, but they threw it away because they came up with a bad model of the ether, not because the ether in and of itself isn't sound. So it just blows my mind, the clown show that's in charge of science here. Okay, so let's take the K plus 1, and I'm going to show you how to convert it step by step so that we can arrive at new electromagnetism magnetic force model, fragmentary magnetic force model. Okay, so again, we start with this guy, and we'll match him up to one of the two identities. We could use either identity here. And so we're going to match this one up with this, including the sign. And that would mean that we want DLT here. This guy would match up with this. And then this, and then we convert and we get this guy here, just like they got. But we're going to keep this other term here. Now, the interesting thing you will note, and I didn't know this until I developed Vortrix algebra, is that this are a very important pattern in Vortrix algebra. Because in two-dimensional Vortrix algebra, not three, but in two-dimensional Vortrix algebra, a cross product plus a dot product is a complete product. And so what we want to do now, we want to isolate this to one side. And so either we need to take this DLT and put it on the left, or we need to take this DLT and put it on the right so that we can have the DLT on the same side of this standard product. So we're going to go this route. We're going to swap this guy over to this side, which is going to incur a negative sign. Okay, the next thing we want to do, we want to get rid of the negative sign. So we're going to swap the interior components. But we also need to do the same thing over here. So this swap, because it's a swap of a cross product, will negate the negative sign. The swap of the dot product will not incur a sign change. Okay, so now what we have is we have a Vortrix product. Okay, and now we got this Vortrix product multiplied by a cross product, and this would effectively be a dot product. This would satisfy as a dot product. So we have two Vortrix products here. And so we can write that for 2D systems. We can go from this in the 2D space and come up with this model here. Now this is a Vortrix expression. These brackets mean that these two vector multiplications are a matrix. This is to be a matrix multiplied by a vector. Now, the fragmentary magnetic force model has R divided by DL. I'm sorry, DL divided by R. And in Vortrix algebra, a left multiply of a unit vector works out to be the same thing as a right divide of a unit vector. So we can replace that. Now this turns into a non-unit vector because now we're going to take one of these R's, bubble it along, take this magnitude of R, multiply it by direction vector of R, which turns into a normal vector. And this, my friends, is the fragmentary magnetic force model of new electromagnetism V5. And I'll show you that this isn't the full new electromagnetism. This is just one small derivative part. But it could have been a gateway for getting into the full new electromagnetism V5. So if we look at how this fits into the new electromagnetism universe, I'm going to show you how we get to the fragmentary force model. So electrogravity starts off ethereal mechanics. So we have a pretonic field and a gravitational field. This red line means you can't have one without the other. If you're making a pretonic field, you have to consume medium, and the consumption of medium is what forms the gravitational field. So all electromagnetic fields are sourced by the energy of the consumption of the medium, which is the gravitational field. You can't have one without the other. The time derivative of the pretonic field gives you the electric force model, which basically replaces Coulomb's model, the magnetic force model, and the inertial force model. Inertial force model replaces Faraday's law. Then, if we take these models and we derive them further, we can come up. Now, this FV means there's a force model and a VIM model. VIM is our new replacement for EMF. So there's two variants of each of these models here. And so the inertial force can be derived into the Coriolis inertial, Venturi inertial, centripetal inertial, and fragmentary inertial. And the magnetic force can be the fragmentary magnetic model. Well, this is the model that we matched with K equal +1. And they also have the Hall effect magnetic force models. So that's new electromagnetism V5. There's a couple other things here. Okay, I don't want to show them all because, you know, we'd get too busy. And just to show you for completeness what you can see out there already. Okay, we haven't published the cosmology paper yet, but this part here that shows that the inertial force is the gravitational force. Yes, we had to split gravitational field from gravitational force. The inertial force and the gravitational force are one and the same. And this is shown in the paper Electrogravity or the video series. So you don't have to wait for cosmology to see this, but this will be part of cosmology. There's going to be a whole crap load of other stuff here that I haven't released yet, but that's where we're going. That's the future. Okay, so summary. Ampere was on the correct track, but he chose wrong, K equal -1. And this came up with the model that Andrei Assissis is promoting, but this model fails scrutiny to no end. Those who chose K equal +1 were on the correct track, but they threw out the longitudinal terms for ridiculous reasons. Had they knew what they had, they would have had 100 years ago or over 120 years ago, they would have been on the track to get new electromagnetism V5 because that would have been the gateway into it at least. It wouldn't be the full thing, of course. It would be definitely a gateway in there. Okay, and they still would have also needed to complete vector algebra to really make full use of this. You cannot use straight up vector algebra to repeat the degrees of freedom. It's only in that one little case things cross over and match, but the full degrees of freedom require vortex algebra here. Okay, so I am done reviewing legacy models. There should be no others out there. And because we really do need vortex algebra to properly express all the electromagnetic effects, anything that I see from Ampere or Weber or these guys is not going to measure up because it's developed in mathematics that even predates legacy vectors. Okay, so and Ampere at K equal +1 is the best thing I've seen out there right now from all the legacy stuff, even though you still need vortex algebra to properly express it with all the degrees of freedom. Okay, so I'm not going to waste too much time. I've got limited time as it is to review legacy models. And thank you. I want to thank my Patreon members for finding this. And I pretty much think we own electromagnetic theory now. I'm not scared that there's something out there that's going to upset what we're work going forward. Now, because of this video was hard to produce because it just gets so detailed and so involved. I kind of delayed the new electromagnetism V5 paper, and I'll post the update actually this weekend, and I'll make it a public posting so that people that aren't Patreon members can go to the Patreon site and see what the release schedule will be. Anyway, thank you very much. And if you have a stomach for a real quest, then please help out where you can. Thank you. No more voodoo physics.